on buckling, on long column. Make sure before starting to solve the problem related to the column, please make sure what type of column you are working in. If the problem did not mention, what is the type of the column? Is it long column or short column? You have to figure it out. You have to figure it out, because one of you will say, hey, this, we have a P ultimate and we have a moment. Okay, probably I can use 100 with the maximum moment 80 and use interaction diagram directly. If this column is short, I'm gonna say the ultimate load is 100 kb, and the M ultimate, which is the maximum value of moment, we have two values. I will use the maximum value 80. So I'm gonna use interaction diagram to figure out the value of rho and then area steel. That's it. If this column is short. But if this column is long, I need to adjust the bending moment a little bit to consider the effect of buckling. Do you remember? MC equal delta M2. M2 here will be 80, the biggest value. Then I will use the interaction diagram, but with P ultimate and MC. This value will be bigger than 80. So make sure you have to check this column is long or short. Probably the problem will not mention that. Any question for this point? Any question for this point? Good morning, Roberto. Looks good? Okay. So please go ahead and check. But before checking, so M1 is given 75. M2 is given 80. Can you tell me which one is positive, which one is negative? M2 is positive all the time. What about M1? Is it positive or negative? I need to check. This one is single curvature or double curvature. You can figure it out with yourself. If you have a beam, if you have a column, and this moment like this, and this moment like this, can you tell me what is the deformation of this column? I believe this column will smile like this. So it's a single curvature. So M1 and M2, both of them are positive. If you have a column, for any reason, we have a moment like this, and this moment in the same direction like this. So I believe the deformation of this column will be like this. Double curvature. So M2 all the time is positive, but M1 in this case will be negative. I think the direction of this moment and the direction of this moment will make this column to smile like this. So it's single. This one will be positive, this one will be positive. Thank you, Oliver. Thank you. Okay. Okay. One more thing. We need to check, do you remember the K, L over R with the relationship to 34, I think, minus, do you remember? Cannot remember. 34 minus 12 time M1 divide M2. What is the value on this side, the left side? Okay, go back to the problem and read it carefully. It is bent about its y-axis with the factored moment shown. with unsupported length 16 and the K factor is 1. So 1 times 16, I'm gonna multiply it by 12 to be an inch. Divide R. Do you remember the value of R? Radius of gyration. Yeah, 0.3 times 14. 0.3 times 14. This column is a square. So inside, it doesn't matter. Guys, make sure the top value in inch, because the bottom value is in inch. This value will be 16 times 12 divided 0.3 times 14, 45.71. The other side, 34 minus 12 times M1, 75. M2, 80. This one is positive. This one is positive. Make sure you are putting the right sign, because the sign will change everything. So this value will be 22.75. So this term is greater than this term. So you are talking about long column. You are talking about long column. Any question? Any question? Okay. Next step, we need to figure out delta C, I'm sorry, MC equal delta time M2. Delta equal CM, I think, 1 minus P ultimate divide 0.75 BC. Do you remember these steps? There you go. CM divide 1 minus P ultimate divide 0.75 BC. P ultimate is given how much? 100 kip. P ultimate equal 100 kip. CM, do you remember the value of CM? I think 0.6 plus 0.4 M1 divide M2. Do you remember that? CM, there you go. 0.6 plus 0.4 times M1 divide M2. I can finish it right now. 0.6 plus 0.4. What is the value of M1? 80. M2. M1? 75, I think. 75. Make sure you are putting the correct signs, because if you have negative, everything will be changed. The value of CM here I'm sorry, -6.975. Guys, make sure that the value of CM is correct. Okay. P critical. Do you remember the value of BC? Critical buckling load by square EI divide KL ultimate square. It's they are very simple steps, but you need to make sure you are doing everything good related to units and values. E of concrete equal 57,000 square root of F prime C. what is the value of F prime C? 4,000. So the value of E concrete (36.04996) PSI. I gross for this column 14 times 14 cube divide 12. It's a square. 14 times 14 cube divide 12. So the value of EI equal, I think, 0.4 E concrete I gross divide 1 plus beta. I think. Do you remember that? Yes. EI in this term equal 0.4 E concrete I gross divide 1 plus beta. Do you remember the value of beta? 1.2 dead load divide P ultimate. Go back to the problem. The P ultimate is given 100 kip. P ultimate is given 100 kip. And the value of dead load is given 50 kip. Dead load only. So I'm gonna multiply it by 1.2 times 50. So this value will be 0.6. So I can figure out the value of EI. 0.4 times E concrete 36.0499 times I gross 3,201 divide 1 plus beta 0.6. So I can figure out the value. This value will be 288489324 pound inch square. So the value of B critical will be, I can get the final answer directly. This value times pi square divide, what is the value of LU? 16. So B critical will be 77.2 kip. Guys, I have a hint here. Please, when you are doing these calculations, make sure K times LU in inch. So if you remember, K is 1, LU unsupported length 16, but 16 in feet. So I have to multiply it by 12. All of these numbers square. Be careful. We don't have anything in feet. Everything should be in inch. Uh, 36. Yeah, I did this, I think. 36. There you go. What is the problem? Oh, you mean we have 6 at the end? Oh, I forget it. Sorry. What about the... Okay. Yeah, this number will make a big difference. Thank you, Oliver. 8049 time by square divide, yeah, thank you. This value will be 772.3 kip. That makes sense. Thank you, Oliver. So guys, go back here. The value of CM 0.975. 1 minus P ultimate 100 divide 0.75 time B critical 772.3. I can figure out the value of delta. This value of delta, make sure it must be greater than or equal 1. So 100 divide 0.75 times 772.3 plus 1 975. This value equal 1.178. So the value of MC, which equal delta M2, will be delta 1.178 times M2, which is 80. Your value will be 94.3 kib foot. So guys, finally, your column with 14 times 14 inch under the effect of P ultimate equal 100 kip. The applied moment right now 94.3. Why? The value is 80 because I considered the effect of buckling. Kip foot. We have steps for interaction diagram. First step, Pn equal P ultimate divide phi. This phi equal 0.65. Mn equal M ultimate divide phi. This phi 0.65. What is the value of gamma? Your steel reinforcement will be in this side and this side. The distance between this layer and this layer equal gamma h, and the value of h equal 14. Go back to this problem. The distance between this side and this side, how much? 9. So gamma h equal 9. Gamma times 14 equal 9. So your gamma equal how much? 0.6. I need to figure out two values, Kn and Rn. Do you remember that? Kn equal Pn divide F prime C area gross. Pn time E, I forgot something here, E. Mn divide Pn. Or M ultimate divide B ultimate. Both of them the same. Anyway, divide F prime C area gross time H. From this value and the interaction diagram, I can figure out the value of rho, then the value of area steel. What do you think? Looks good? Long but easy, yeah. It should be long because you are staying at home and you will solve the exam at home. So this point is very important. Please make sure. Probably I will give you the problem without saying it's long or short. If the column is long, we need to take the effect of buckling. How? By getting a new moment, MC, equal delta time M2. This delta will consider the effect of buckling. But if the column is not long, the column is short. If the column is short, you don't need to do all of this stuff. You need only to say, hey, P ultimate from this diagrams or these values, 100, and the M ultimate, the maximum value from this one and this one is 80. Go ahead and use interaction diagram directly. If the column is short, but the column is long, we need to do some calculations first to consider the effect of buckling. That makes sense? Besides, Burak, you are at home drinking tea and water and milk and eating everything. So what's the problem? You can expect 10, 20, 30 problems in the exam. Don't worry, guys. The exam will be the same like the last one, 5 or 6 problems. You will spend, I think, 2 hours maximum in solving the exam. Okay. So this is the design of a column. How to design columns. Any question related to design of columns? I have a question. Okay, whatever the type of the column, short or long, spiral or tied, we have to figure out a value of P ultimate. Anybody can tell me how can I get the value of P ultimate? I'm asking right now about a question related to structure analysis a little bit. So what is the meaning of P ultimate? What is the meaning behind P ultimate? I believe it's a reaction. That's right. P ultimate is a reaction. Guys, are you here? We have a beam. And this beam is supported here by a column and supported here by a column. So the reaction coming from this beam will be P ultimate. That's right? Or we need to do something. So before you learned how to reach finally to a beam with uniform distributed load W ultimate. Do you remember that? So we can draw bending moment. That's fine. So if you solve this one by structure analysis or by RISA and figure out the reaction on this support, do you think this reaction will be the value of P ultimate? Or something else? I believe yes and no. Any help? That makes sense because we have a beam and we have a column. So the reaction from this beam to this column will be P ultimate. I believe that. Do you believe the same? You will include the own weight of the beam. Don't worry. The own weight of the beam, this beam including everything for slab, for beam, for on weight, for everything. So this reaction will include everything for this beam. What do you think? Okay, I can explain it in more details. I think if I open the previous module, this one. Yeah. So guys, right now we have this slab supported by these beams and this beam supported by this column. So the reaction from these beams to this column will be P ultimate. No. Why? Why? We missed something. You should answer this question, guys. You missed something. You missed something. You have a beam, this beam. You considered the on weight of the beam, the weight coming from the slab, the life load, everything. And finally, you have distributed load here. If you solve this beam and get out the reaction here, this reaction can be considered the P ultimate on the column, or you missed something. I'm trying to give you the information by a question to don't forget it all the life. Burak, you are trying to write something, and Cody and Oliver, but I didn't see any response yet. Brian also trying to say something. Or you are chatting with each other. No, it's not lateral load. We didn't talk about, in this course, we are not considering wind or earthquake. It's more advanced level. I hope if we can cover this level in the capstone project. Okay, I will answer the question. But I have some of you are trying to write something, or you are chatting with each of you. Are you chatting? Yeah, your answer, Cody, is correct, but you're still missing something. your answer is make sense for me and makes sense for everybody. But there is a big mistake you missed. And if you didn't consider this mistake, believe me, collapse will happen to the building. Wow. Collapse? Yeah. Okay, let me answer this question. Let me answer this question. Guys, can you watch for this building? We have another story here, another floor. And probably we have another floor. And probably we have another floor. I know this floor, which called typical floor, will be the same like this one, will be the same like this one, will be the same like this one. Yeah, I agree with you. But the reaction coming from this beam only is the reaction from this floor only. But this column or this column or this column is supporting this floor and this floor and this floor and this floor. So the value of P ultimate must be reaction from the beam in one floor. I agree with you, and I agree with Cody, and I agree with everybody of you, but you have to multiply it by N number of floors in the building. Number of floors of the building. Guys, B ultimate on the column, it's not only the reaction of one beam. I agree with you. Reaction of one beam is the reaction on this column. That's right. But this reaction coming from one floor. Probably this column is supporting multi-story floors. So you have to multiply this reaction by number of floors in the building. We have a big difference here between design of beam or slab and the design of columns. Beam or slab, we are talking about loads from one floor only. If you are sitting on the floor right now, your load only to this floor only. No relationship between your weight or your load and the floor upstairs. But if you are talking about column, I'm talking about a column in the ground floor, in the first floor. This column is supporting what? This floor, this floor, this floor, this floor, this floor, this floor. Probably each floor will give you the same reaction, I know. But this reaction must be multiplied by this one and this one and this one, so the number of floors. Did you get it? Guys, did you get the idea? Okay. So probably I will ask you another question during your interview with a work or something like this. Guys, what will happen if a beam, if you have failure in a beam or slab in one floor? And what will happen if you have failure in a column? What is the difference? You will say, hey, both of them are failure. No. This failure in one beam or part of the slab is local failure in one floor in the building. I can solve this issue. I can strengthen, I can upgrade this local failure. But if you have a failure in a column, this failure will not affect only for one part. It will affect for the whole building. if this column in the ground, in the first floor. So make sure you are designing column correctly. Make sure to be generous, more generous with designing a column, because some of you will say, hey, the design give me a dimension of this column. The calculations exactly give you 12-inch by 12-inch, and the area steel is 3 and more 3. Be more generous. So the calculation give you 12. Okay, I'm gonna make them 16 times 16. Believe me, the difference in cost is nothing. Nothing. Cost of column is nothing. But factor of safety for column is very, very, very important. So make sure designing of column is critical. Okay. Guys, for homework number 5, if you go back to this homework, most of you did something wrong here. Many mistakes. As I remember, Vn equal Vc plus Vs. Vc inbound, Vs inbound. So Vn will be inbound. If you would like to convert it to kip, you have to divide by 1000 only. Because as I remember, some of you assumed Vc inbound inch. No, it's not a moment. It's a shear. It's not a moment. So they divided by 12,000. No, it's inbound. So make sure you did the units correctly. One more thing. For designing of torsion, we have 3 steps. The first step, you need to check if we will ignore T ultimate or not. The second one, make sure the cross section of concrete 12 times 30 is okay or not. The third step, we need to figure out the value of area T divide S. Most of you did this step incorrect. I'm not sure why. Let's do it with you. I think it should be this one. Yeah. Torsion. Here you go. This is a value. Square root. Some of you forget this square. Some of you forget this square. So please make sure you put everything in this equation in pound and inch. Everything. I believe in this problem, we don't have shear. So this term will be cancelled. T ultimate. T ultimate in this homework is given by kip foot. So I told you, make sure everything in pound and inch. So this value will be 65 times 12,000. 12 for feet, 1,000 for kip. So this value of T ultimate will be 65 times 12,000. PH. PH is the perimeter for the center line of the stirrups in inch. Divide 1.7 area OH square. This term only, this term area OH which equal x1 times y1, the area inside the stirrup center line, this term only square. After you did this value, square, then get square root. Other side, VC must be in bound. T, D, inch, F prime C, PSI. So I can decide the cross-section beam is enough or not enough based on this relationship. Okay? So please make sure you did this relationship correctly, because Burak, for example, found the cross-section is not enough, so he stopped. Most the other student, no, the cross-section is enough, and they continue and they found what is the value of area T divide S, and they find spacing, I think around 2 inch or something like this. Okay, so make sure you did this relationship correctly, because I believe the cross section is enough and you should find spacing and stirrups. Okay. Any question? Any question? So guys, you can expect one problem on shear stirrups. Okay, you can expect one more problem on torsion. One more problem on designing of a slab, one-way slab, and another problem on two-way slab. 2 or 3 problems on column. So the total will be probably around 6 or 7 maximum problems. Okay. Yeah, go ahead. What is your question? You should round it 0.6 or 0.7. That's fine, because we don't have interaction diagram available for anything in between. But if you need the best answer for this question, for example, if you have gamma equal 0.64, the best answer is you have to try gamma equal 0.6 and find what is the value of rho. And you have to try gamma equal 0.7. And you have to try to get rho. The value of rho, it's not this one or not this one. Your rho will be something in between. How can I find the value of rho in between? By interpolation. You know what I mean? So something between half this one plus this one divide 2, probably, if this one is 0.65. But 0.64 will be closer to this value. You know what I mean? So, but in this course, we don't need to do all of these calculations. 0.654 will be 0.6. 0.66 or 0.67 will be 0.7. That's fine. This is the best answer. You have to figure out using gamma for the smallest value, for the greatest value, or the greater value. Then the actual value will be something in between by interpolation. Okay. So in the exam, if your value is 0.64 and you assumed at 0.6, that's fine. If you assumed at 0.7, that's fine.